Hi everyone, today we're going to talk about indicators. So an indicator is a substance that changes colors when the pH changes. And there are hundreds and hundreds of indicators. Some of them are natural, like for example, red roses, what gives them the color red. That is a pigment, that is an indicator. Same thing with purple cabbage or red beets. Those are all natural indicators, and some, of course, are synthetic. But a lot of the indicators are big organic molecules that are weak acids. And a lot of the big organic molecules, if they have alternating double bonds like you see here, they have a color to them. And because it's a weak acid, what happens is when you put it in a base, that hydrogen can be donated. Remember, an acid is a proton donor. So when it gives away a proton or an H+, it changes its structure. And because it changes its structure, the way that the double bonds are makes it have a different color. And so this is phenolphthalein, for example, which is an indicator. This is what it looks like in the acidic form, which is clear. Or colorless, I should say, and in the basic form, it turns pink. Like I said, there are hundreds and hundreds of indicators. Here are a few. So some indicators turn all kinds of different colors. For example, universal indicator can turn all kinds of colors of the rainbow. Those tend to have a lot of hydrogens that can be given off. And so every time you give off a hydrogen, it changes a different color or a different shade. A lot of indicators, though, just have two colors. So we just talked about phenolphthalein, so it could be either colorless or pink. Something like M-nitrophenol could either be colorless or yellow. Something like bromophenol blue could be shades of yellow and blue, and in between it would be green. So some of them, like I said, have just two colors that they could be. Others have multiple colors, 3 or 4 or even more. Also, not all indicators turn at a pH of 7. So the example we've been talking about, phenolphthalein, it turns around a pH of 9. So anything below 9 is colorless. Anything above 9 is pink. Others will turn at a pH of 7. Others will turn at a pH of 3 or 4 or 5. And so each indicator turns at a different pH. They don't all turn at a pH 7. So, if I'm comparing between like a really strong acid versus a weak acid, maybe I want to use an indicator that's here, to detect a pH change of 1 to 2 or something like that. Versus if I want to check if something is neutral or acidic or slightly basic, I'd want to pick something that's at 7 and so on. So again, different indicators turn at different pHs. Like I said, there are hundreds and hundreds of indicators. The main ones that you need to know are these 3 right here. And some of them you've used before. So you've probably used pH paper as opposed to litmus paper. pH paper is like an orange color almost. And when you put it in a neutral solution, there is no change. When you put it in an acid, it turns like a darker orange or a red. When you put it in a base, it turns into a blue or purple. Whereas litmus paper comes as either red or blue. And so if you start out with red litmus paper, in an acid it remains red, neutral remains as well, but it changes in a base, it turns blue. If you start out with the blue litmus paper, then in a base or in neutral it remains blue, but in an acid turns red. So with litmus paper, acids are red, bases are blue. In a neutral solution, there is no change. pH paper is pretty similar, except pH paper is kind of a variety of different colors, not just blue or red. It shows you the whole spectrum, the whole rainbow. Universal indicator is my favorite indicator. that also turns all colors of the rainbow. So green is neutral, and anything that is yellow, orange, or red is acidic. Anything that is blue or purple is basic. And then phenolphthalein is the most commonly used indicator when we do labs, and it is colorless in neutral and acidic solutions. At around pH 9, it turns pink. So you do need to know those three indicators. But again, remember there are hundreds and hundreds of other indicators. I'm going to get some indicators from the lab, and hopefully I will do a demo for you to show you some different indicators. But if you want to try at home, red cabbage juice works really well, or even just red cabbage leaves. If you buy some, you can try at home to, dip that in water, then dip it in like vinegar, which is an acid. Try to dip it in dish soap, which is a base, and look at the different colors that it turns.